Corporate finance practice problem using OneNote, asking the question how much to invest to reach a particular goal, both in terms of one investment type of calculation and in terms of an annuity, comparing and contrasting the two. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you have access and would like to, we're in the tab on the left-hand side. We're in the practice problems area, and then down here in the 940, how much to invest to reach goal, one investment versus annuity tab. Also note that when using OneNote, you may want to look at the immersive reader. Many of our presentations will have a text format to them, which has the same number as the presentations, and they will have transcripts that can be translated into other languages and both read or listened to in other languages, thereby being a good complement to the presentations up top. If you do take a look at those, please give us some feedback and see if they are useful to you. So we're going to have our information up top on the left-hand side. We're going to go through the calculations of that information in a few different ways down below. The scenario will be, we have an investment goal of the 30,000. The years are going to be 12. The rate is going to be 12%. And the question is how much to invest if we make one payment. So we're looking for the payment item here. If we have one payment that we're going to be putting in place to reach the goal, meaning starting point at this point in time, we invest some point and we want to reach the goal of the 30,000. So we'd use a present value type of calculation for that. Then we could also ask the question, how much to invest if we make 8 equal payments, meaning our end goal being the 30,000. If I pay in an annuity type of fashion, what type of payments, how much payments do we need to be making in order to reach that goal, once again, of that 30,000? That being a little bit more complex of a calculation. We'll take a look at that in the second component. So first, we have one, if we're trying to say, okay, I want to put in some money today and I want to get to the end result of the 30,000, then you would kind of think that you'd start off with the payments that you would be making and then try to figure out where you would be at the end. You could do that, but it would be a trial and error type of method. Or you could take the end goal, the goal being the 30,000, and basically present value that. So that's going to be our first type of method. We'll present value the single item of the 30,000. Note, when we do this, of course, we do have to assume what the rate is. So we got to make sure that we consider what we think they're going to be the rate. Once we have that and the periods, then we can go through our calculation. We'll start it off with a present value formula, and then we'll calculate it a few different ways as well. Formula, present value equals a future value times or over 1 plus r to the n. We're going to break that into a table kind of format down below. So we'll have the numerator divided by the denominator in the outer column, and then we'll go inside here to break out the denominator, considering it's a bit more complex. So we have the 30,000, that's going to be the investment goal. So the investment goal, future value, 30,000. Then we have the 1 plus r to the n, which is going to be the denominator. So we'll start off with the 1 plus r, which is going to be the 12% given to us in the problem. Adding those up, 1 plus the 12% is going to give us 112%. We then take that to the power of number of periods, in this case in years, 10. So I'm going to pull out the trusty calculator and do that calculation. Note that when we take it to the power of 10, we're going to need a calculator that can do that. In Windows, I'm going to hit the tab on the left, go to the scientific calculator, and calculate it in a scientific-y kind of way. So it's going to be 1 plus the 0.12. That's going to be the 1.12 or 112% to the power of, which I'm going to use this x to the y. And then that's going to give us our caret up top, 10. And there we have the 3.1058 and so on. So let's go ahead and reveal here. The reveal. And so there it is. And then we're going to take that amount and divide this out. So if I divide this out, let's go ahead and clear this. We got the 30,000 divided by about 3.10585. Rounding is in effect. We've got the 9659.19. Is going to be what we have here, about. And then this amount is a figuring of the table. So we could think about, okay, if I look at the tables, how would we build the tables, which we'll look at later. You could take then, all right, well, if I take this 9659.2 divided by the 30,000, then we can approximate, what we will see on the tables, which we'll see at a future point calculating this problem. So that means that in order to get to our goal of the 30,000, if we put in a lump sum payment today, we have the years of 10, rate 12, we're looking then the 9,652.20. So now let's do it again. Let's go on down and say, well, what if we do this with like Excel? If we did this basically in Excel, we'd have the Excel function or formula that we can put this in place with. So that would be equal the present value, and then we're taking the rate, that would be the 12%, comma, the number of periods, that's going to be 10 in our practice problem, comma, we don't have anything for the payment because this is not an annuity, as we'll see shortly, an annuity, but this one is not, comma, future value, that being the 40,000, will once again give us the 6,000 or 9,659.20. We can also do this with a table, of course, table time, same kind of thing down here. We got the periods 10, rate 12, periods 10, 12, 12, 10. So I'm going to say 12 and then 10 is going to be the 0.3220. So we could also take that 30,000 times the 0.3220, giving us that 9,660, close to but not exact, the 9,659 that we got to in the other calculations due to the rounding tables only taking it out to 4 digits. If we were to take it out to a few more than 4 digits, it would look something like what we calculated up top at 0.321973 and so on. So that's going to be the difference in the rounding, probably not big enough of a difference to have an impact on decision making, but be careful of practice problems, multiple choice questions, which could take advantage of that difference to force you to use, say, the tables or not to use the tables. Let's take a look at the second one and say, okay, we have the same thing here, but this time, instead of us trying to put in one lump sum to then get in 10 years that 30,000 at the 12%, what if we put in an annuity type thing and we put in the same amount? How much do we have to get then to reach that end goal of the 30,000? So we could use basically a present value of annuity type of calculation, similar kind of thing here, but we'd have to solve for the answer because we're looking for basically P this time. We're looking for P, not the end present value, which would be the 30,000 of the annuity. So you can use the same formula. You could do this algebraically, which means you would say the end result would be 30,000 equals P, unknown, times 1 minus 1 plus R, 12% for R, to the negative N, 10 would be the periods for N, over R, which would be 12%, that giving us simply one unknown, which we can then solve for algebraically. That's one method we can use. I won't go through the algebra here, but obviously you'd solve for P, you put it in there, solve for P. Many book problems might have something similar to that in order for you to use the algebra to solve for it. We can also say, well, if I was using like Excel or some financial calculator, is there some way I can do this as well? Because if I know the present value of an annuity formula, I might not put it in. I don't have a formula really to do it algebraically. Is there some way I can use like Excel to back into that number in a similar way as we would if we only had one unknown, even if using a function? So for example, if we go down here and take a look at our Excel formula, you might say, hey, this is not exactly a mathematical formula. I can't rearrange this algebraically to solve for something other than the present value of the annuity, which is going to be the end result here. But we can still use a tool to do something similar, meaning we can enter the formula up top and then use basically a goal-seek tool, a trial and error type of method to solve for something other than the end result of the formula. Therefore, in a similar fashion as with algebraic equations, if we know an algebraic equation, we know all the factors and only have one unknown, we don't need to memorize another equation, which would just basically be the reworking of that first equation to solve for a separate unknown. We can instead use that same equation, similar kind of concept with the function. If I know one of these items, rate, number of periods, payment, and so on, and then the amount, then I can back into it with a similar kind of item, but using a goal-seek type of feature. That'll be in Excel. Highly recommend taking a look at it in Excel, but we'll kind of go through the concept here first. So once again, you can do it algebraically, solving for P, that being the unknown. I'm going to take this algebraic equation, break it down into the table as we have seen in prior presentations, and then consider how this kind of trial and error method would work. And then we'll discuss it with the function, which will be more likely what you would do basically in practice. So let's take this equation, P, I'm going to have P times this whole thing in the outer column, and then in the inner column, we'll have the numerator and denominator, focusing in on the numerator, it having more detail to it. The first item will be the payment. Now this would be the unknown that I'm going to plug into the formula and then basically solve for that using trial and error, which in Excel we can use a function to basically solve for that. So normally I would start this off with something other than, something like 1,000. I wouldn't start it with 0, because if you have 0 in there, then if you divide by 0 or something in a particular type of equation, it could mess the thing up. So what you want to do is start with something there. I would typically start with 1,000 in this item. That's what we would be solving for. Then we have the 1, which is going to be this here, and then 1 plus r to the negative n. 1 plus r to the, that would be 112% to the negative n. Number of periods would be 10. So 112 to negative 10 would be this number here. So then we're going to have 1 minus that number. 1 minus this number gives us this item. And then we're going to take that and divide it by the denominator, which is once again going to be the 12%. That gives us this value. So now we've calculated, we have P up top and this value here, and that would give us then our end result as we multiply that out. Now obviously here we have the end result, that being the 5,309.52. But if you had this all connected within Excel, the concept here would be that if I just plugged in 1,000 here and then started changing the number, instead of reworking the algebra, I can simply do trial and error for this particular number until I get to the proper end result, in this case being the 30,000. That would be the concept that we'd have. By hand, that would be a very tedious thing to do, and it would be much faster to rework the algebra in order to do that. But if you have a function and you have everything connected with formulas, then it's not difficult to rework this first number and have everything recalculate. And Excel has a function called goal seek, which will help us to do that. So we'll practice using that in Excel. That's just like the concept of it. And then Excel can basically give us this number basically back into this number without us adjusting or changing our spreadsheet, our format. We just calculate it from top to bottom. I'm not going to write another spreadsheet. I'm not going to basically rework the problem algebraically. We're just going to back into that unknown. Once we have that concept, then we can apply it to what would be more common in Excel. That would then be the function. So oftentimes we don't know what the mathematical formula is, and I certainly don't want to go through the algebra, especially if I have a very complex mathematical formula. What I'd like to do is use the function that I know in Excel, and this I cannot rework algebraically, but I can think about it in a similar way. This is going to be the present value of an annuity function. I know the end result of it needs to be the 30,000, so I can plug this in a similar fashion and then find the unknown. So once I would start then with the payment down here as the unknown, I would plug something into that cell, like $1,000, and then adjust that in a similar fashion, basically forming kind of like a similar algebra kind of concept so that we can then find that unknown. So then if I put this into our function, we'd say this is going to be the rate. The rate is known, that's going to be the 12% up top, comma, the number of periods, that's known, that's going to be the 10 periods, comma, and then the payment, that's what's unknown, which we would then put into another cell, for example, putting simply 1,000 or something in it other than 0, so it will calculate something. Let it calculate. It will then give us the end result of calculation, most likely something other than 30,000, the answer we want. And what we would then do is then say, okay, I know that the end result should be 30,000. What can I do in order to get to that point? Well, I can change this cell, the unknown. I can keep changing that cell to get closer and closer to the 30,000. And I can use a function within Excel called goal seek to do that trial and error method for us. So in that way then, if I know the function, which is a common function, present value of an annuity, and I need to solve for the payment here, I'm not going to go look for another function for the payment, just like I wouldn't try to find another algebraic equation for the payment, but rather in algebra, I would rework the equation to solve for the unknown of the payment. I wouldn't memorize the other formula. Here, same concept. I don't really want to, I could, but I don't really want to look for a formula for the payment. I'd like to use this same function and back into that unknown, and the way we can do that is with trial and error, basically a goal seek type of method. Highly recommend taking a look at Excel to do that. Now we can also back into this with the tables. So if we use our table kind of format, then this would be something that you wouldn't do so much in practice most likely, but a book problem might try to kind of force you into doing this in a reverse way, basically using the tables to do that. So here we would know the end result being the 30,000, and then we would also know the table amount. We can actually find the amount on the table and then back into the payment amount. So in other words, the amount on the table should be 12 and 10. So we have the 12% and 10, which is the 5.6503. That would be the 5.6503. If I know the 30,000 and the 5.6503, I can back into then the payment amount. Usually it's going to be this times this equals 30,000. Now we know the bottom two numbers. So we're going to then take the 30,000 divided by the 5.6502, and that'll give us then our payment amount, which is the 5309.545310 about. So they could ask you that. A book problem may well ask you that in terms of the table, because you can basically back that into a table and try to take your financial calculator away to figure that one out.